Another class of chemicals that we're going to name are acids. Acids are fairly easy to identify because the first element in the formula is a hydrogen. And acids are broken down into either binary or oxyacids. A binary acid has just two elements, and we know that one of them is hydrogen, so it's going to be hydrogen written first and then one other element next. As an example, this chemical HCl is an acid. The naming of binary acids always starts with the prefix hydro. So HCl is hydro, and then the name is based on the second element listed. Chlorine is going to change its ending to an ic. So this is hydrochloric acid. Notice there's a space between the end of the hydro, in this case chloric, then a space, then the word acid. Binary doesn't just mean two atoms, because you could have a binary acid between hydrogen and sulfur. Remember, sulfur would make a -2 charge. Hydrogen would be a +1 if we were forming an ionic compound. So this is a way you can figure out how many hydrogens it takes to neutralize a certain element, but don't confuse this with being an ionic compound. H2S is still a binary acid, so we're still going to name this with the prefix hydro, and then the element sulfur. It would be nice if it just changed to sulfic, but chemistry is not that nice in the naming system. It sounds better to say sulfuric. So this is hydrosulfuric acid. Oxyacids, surprisingly, contain oxygen. So these oxyacids will be made up of a polyatomic that you memorize from table 5.3, such as nitrate, NO3 with a -1 charge. If we were going to make a neutral compound, and it doesn't matter whether it's acid, molecular, or ionic compound, every compound has to add up to a net charge of 0. So if we were doing the crisscross with hydrogen +1, we would get the formula HNO3. And I'm not saying that this is ionic, but this is a way that we figure out the formula. So we see HNO3, H is written first. This is an acid. It's not binary, it's oxy. And the naming system is based on the name of the polyatomic that makes it up. In this case, we have a polyatomic that ends in ATE. Remember, they will all end in either ates or ites. If it comes from an 8 anion, we change the ending to an ic acid. So HNO3 is nitric acid. We also have a similar acid, HNO2. HNO2 came from the polyatomic NO2-1, which is the nitrous anion. And if it ends, I skipped ahead. That's not nitrous, that's nitrite. I skipped ahead and gave this away. The ite ending turns into an OUS. So when it's an 8 ending, we change it to an ic. If it's an ite, we change it to an OUS. So HNO2 is not nitric acid, it's nitrous acid. We also have a reminder about diatomic elements. You might see a problem talking about oxygen gas. So we're not talking about a compound at this point, but remember the diatomics are the Hunkelbrief elements. And each of these is most stable when it's two atoms connected together. So we're not talking about naming a compound. These are not compounds. These would just be molecules because they're not two different elements bonded together.